Good morning, students. Today we are going to start with the next part of last unit, that is waves. What do you mean by waves? Wave is a form of disturbance in which the energy is transferred or that disturbance is transferred from one point to another point of the medium. This is point 1 and this is point P2 to the medium without any actual transportation of the particles of the medium. Right? What happens if you say these are the particles of the medium? Then one particle disturb the other, second disturb third, third disturb fourth, fourth disturb next. In this way, this disturbance travel. So what do you mean by wave? It is a form of disturbance. It is a form of disturbance which travels from one point to another point in the medium without any actual transportation of the particles of the medium. Here particles vibrate about their mean point. In this motion, particles vibrate harmonically about their mean point. And thus disturbance travels. Right? Means if the wave is traveling from this point P1 to P2, so the particles of the medium, particles of medium, and they are vibrating. It disturbs first, second, third, fourth, fifth. In this way, this disturbance travel. Now, for the propagation of wave, the medium must require two properties, that is inertia and elasticity. Inertia and elasticity are the two properties. Which a medium required for its propagation. Right? किसी भी मीडियम में अगर आपको वेव ट्रांसफर होनी है, then propagation. Right? Now the next is mechanism of okay, if we take the example of waves, you can see if we throw a stone in the pond, then what happens? Then the ripples are generated in the pond. Then these ripples is in the form of waves. If you place a piece of paper over it, then what happens? It only moves up and down. It never moves forward. Right? It only vibrate about its mean position. So if we see mechanism of this is waves, mechanism of wave propagation. Right? You can explain it. Mechanism of wave propagation. Suppose this is a surface of water. XY, right? And a point O is present here. Or you can say an atom or molecule is present at point O. When you throw a pebble or a stone, then what happens? It exerts the force on it and it moves from O position to this extreme. Right? Now, due to the property of elasticity, a restoring force is created toward which side? Towards the mean point, right? And at point E1, its velocity becomes equal to 0. Extreme point पे velocity कहाँ हो जाती है? 0. Now, due to this restoring force, it again come back to its mean point, and this restoring force is generated due to the property of which? Elasticity. Due to the property of elasticity of the medium, this restoring force is produced when this particle is displaced from its mean point. Mean point से displaced हुआ, extreme गया, कौन सा force produce हुआ इसमें? restoring force, which always act toward the mean point. Now from this extreme point, it again reaches to this point O and its velocity become maximum at mean point. Now due to inertia of motion, it overshoots. क्योंकि बॉडी अपने आप रेस्ट पे तो आएगी नहीं. इट ओवरशूट्स दिस पॉइंट एंड रीचेस टू दिस सेकेंड extreme. Again, which force is generating? Restoring force. It come back to this mean point and it acquires some velocity, and due to inertia it overshoots this mean point and reaches to second extreme. In this way the particle vibrates. In this way the particle vibrates. Next is types of waves. Types of waves are, I am only introducing types of waves. First is mechanical wave. What do you mean by mechanical wave? These are the waves which require medium for its propagation. These are the waves which require medium for its propagation. Medium for its propagation, right? Second is, first is mechanical wave and next is electromagnetic wave. Electromagnetic wave. Okay, first का अगर हम example दें मैकेनिकल वेव में, लाइक साउंड वेव विच रिक्वायर द मीडियम फॉर इट्स प्रोपिगेशन, इसका हम एग्जाम्पल ले सकते हैं साउंड वेव, राइट. नेक्स्ट इज इलेक्ट्रोमैग्नेटिक वेव्स. दीज आर दी विच डू नॉट रिक्वायर एनी मीडियम, डू नॉट रिक्वायर एनी मीडियम फॉर इट्स propagation. It do not require any medium for its propagation. Third is matter wave or de Broglie wave. Matter wave, these are the waves associated with the moving matter. Wave associated with moving particle, like electron associated with moving electron. ये आपने केमिस्ट्री में पढ़ा होगा, like de Broglie wave. आपने de Broglie wave, moving wave associated with the moving particle, like electron, proton, etc. लाइक इलेक्ट्रॉन, प्रोटॉन. और ये आपने केमिस्ट्री में पढ़ा डी ब्रोगली वेव. और अगर हम बात करें ईएम वेव की, दे डू नॉट रिक्वायर एनी मीडियम फॉर इट्स प्रोपिगेशन. इसमें आप एग्जांपल दे सकते हो एक्स रेज, लाइट वेव्स, ठीक है, यूवी रेज, इंफ्रारेड रेडिएशन, एनीथिंग यू कैन से. लाइट, इंफ्रारेड सन से जो आ रही हैं, यूवी रेडिएशन, एक्स रेज, ऑल दीज आर रेडियो वेव्स. दीज आर द एग्जांपल्स ऑफ ईएम वेव्स. नाउ इन this mechanical wave we will discuss in the class 11th, and these two we will discuss in class 12th. Now after this we have to discuss the types of mechanical waves. Next is types of mechanical waves. One is longitudinal and second is transverse. Longitudinal wave, longitudinal waves, and सेकेंड इज ट्रांसवर्स वेव. क्या होती हैं ये लॉन्गिट्यूडनल वेव्स? लॉन्गिट्यूडनल वेव्स आर द वेव्स इन विच particles of the, in this wave we are discussing longitudinal wave. In this, particles of the medium vibrate in the direction of propagation of wave, in the direction of propagation of wave. Suppose the wave is propagating along this direction, so the particles of the medium also vibrate. This is particle 1, this is particle 2, this is particle 3. So these also vibrate in the direction of propagation of wave. Direction of propagation means direction of motion of wave. The wave is traveling along x direction, so particles also vibrate in this direction, right student? This wave travels in the form of compressions and rarefactions. Compressions and rarefactions. This wave travel in the form of compression and rarefaction. If you take the example like sound wave, vibration in the air column of organ pipe, air column of organ pipe. What do you mean by organ pipe? Like जो आपकी बांसुरी होती है उसमें जो एयर कॉलम होता है उसकी वाइब्रेशन. Sound wave, vibration in the air column of organ pipe. Now what do you mean by compression? Compression is the region in the medium where the particles they come close to each other. Compression क्या है? It is the region where the particles come close to each other, right? यहाँ आपने closeness दिखा देनी है, where the particles of the medium they come close to each other, right? Then rarefaction, then their normal distance, right? कंप्रेशन आपका वो रीजन है जहाँ पार्टिकल्स क्या आ गए, दे कम क्लोज टू ईच अदर देन देयर नॉर्मल डिस्टेंस. इन दिस रीजन द डेंसिटी इंक्रीजेस, density of the medium increases, volume, density of medium increases, volume decreases, pressure increases. pressure क्या हो गया, increase. और फिर rarefaction में क्या है, the particles of the medium move away from their normal. this is compression, this is rarefaction. particles of the medium move away. तो यहाँ density of medium क्या हो गई, decrease, वॉल्यूम क्या हो गया, इंक्रीज, और प्रेशर भी क्या हो गया, डिक्रीज. फिर आता है आपका नेक्स्ट इस पे कंप्रेशंस. या आप इसको डार्क से दिखा दीजिए, दिस इज कंप्रेशन. देन rarefaction where the particles move away, and then compression जो आपकी sound waves है that is travel in the form of compression and rarefaction. And the distance between the two consecutive compression is wavelength, and the distance between the two consecutive rarefaction is wavelength, right? Now after this, if we discuss transverse wave. Transverse wave, in this wave the particles of the medium vibrate perpendicular to the direction of propagation of wave. Suppose the wave is traveling along this direction, this is the direction of propagation. So how the particles of the medium vibrate, up and down, like in this way. The particles of the medium vibrate perpendicular to this direction, and these wave travels in the form of crest and trough. कैसे travel करती हैं ये, crest and trough की form में, like, right? And इसका example है the vibration of the strings of a string of tabla, sitar, vibration of string of a sitar. Second example, vibration of the membrane of tabla. These are the example. Or all the electromagnetic waves like light waves, EM waves are also transverse in nature. How these waves travels? These wave travels in the form of crest and trough. So now what do you mean by crest? Crest अगर हम कहें, it is a portion which is temporarily raised above. This is a portion of the medium which is temporarily raised above the normal position. This is crest, right? And this is a portion which is depressed temporarily below the normal position. ये क्या है, normal position of the medium, right? This portion is temporarily raised above the normal position, and this is temporarily depressed below the normal position. This is trough. Then it is crest. Every crest is followed by trough. This is also trough. And what is the distance between two consecutive crest? It is lambda. And what is the distance between two consecutive trough? It is lambda. Now the next thing is, these longitudinal wave passes through solids, liquids and gases. ये कहाँ से? Through all the states of matter it can be passes. Longitudinal waves can pass through solid, liquid as well as gases, whereas these transverse wave only pass through the solids and on the surface of liquid it can be passes. On the surface of liquid it can be passes. ये solid liquid gases में, और ये solid and on the surface of solid liquid gases में से pass होती हैं, और ये solid and on the surface of liquid. तो question can be asked, which wave can pass through all the states of matter? That these are longitudinal waves. कौन सी waves हैं? Longitudinal waves. Okay, in the next video I will explain the equation of plane progressive wave. Thank you.